FastMCP employs a declarative UI framework that maps Pydantic models to interactive form components, enabling structured data collection through a reactive architecture. The system leverages a form-from-model constructor to generate input fields, validation, and submission wiring from a base model schema, while maintaining separation of concerns between UI rendering and backend tool execution. We are about to examine how a bug report model translates into a functional form interface, with event handlers that invoke server-side tools via CallTool, demonstrating the framework's model-driven UI generation pattern. From typing, import literal. From Pydantic, import base model, field. From prefab UI, components import column, heading, form. From prefab UI, actions, MCP import CallTool. From prefab UI, actions import setState, show toast. From prefab UI, app import prefab app. From prefab URX import result. Class bug report base model. Title, SDR equals field title bug title. Severity, literal, low, medium. High, critical equals field. Title equals severity. Default equals medium. Description, SDR equals field title description. Add app, UI. Def report bug, prefab app. File a bug report. With column gap equals 4. CSS class equals P6 as view. Heading, report a bug. Form from model. Bug report. On submit equals CallTool. Create bug. On success equals show toast. Bug filed. Variant equals success. On error equals show toast. Failed to submit. Variant equals error. Return prefab app view equals view. Add app tool. Def create bug data. Bug report SDR. Create a bug report. Hash save to database. Return F created. Data title. This code demonstrates a clean pattern for creating forms from Pydantic models in FastMCP 3, leveraging the framework's built-in form generation capabilities. The bug report model defines a structured data schema with typed fields, including a string title, a severity level constrained to specific literal values, and a description field. The form-from-model method automatically generates a complete form UI from this model, creating appropriate input components for each field type text inputs for strings and a dropdown for the literal severity options. The form submission is wired to a backend tool via CallTool, which handles the server-side processing. This approach provides several advantages. It reduces boilerplate by eliminating manual form construction, ensures type safety through Pydantic validation, and maintains consistency between the data model and UI. The success and error callbacks demonstrate proper user feedback handling, showing toast notifications for different outcomes. This pattern is particularly useful for CRUD interfaces and data entry forms where the structure is well defined. The trade-off is reduced customization compared to manually built forms, though you can still override specific fields if needed. The Pydantic integration also provides automatic client-side validation before submission, improving data quality without additional code. Let's break it down. From typing, import literal. Imports the literal type from the typing module, which enables specifying that a variable or function parameter must be one of a specific set of literal values. From Pydantic, import base model, field. Imports base model and field from the Pydantic library, providing base functionality for data validation and model creation with field customization. From prefab UI, components import column, heading, form. Imports 3 UI component classes from the prefab UI, components module, column for vertical layout organization, heading for section titles, and form for user input collection. These provide the basic building blocks for constructing a user interface in this framework. From Prefab UI Actions, MCP import CallTool. Imports the CallTool class from the Prefab UI Actions, MCP module, providing functionality to invoke tools within the FastMCP 3 framework. This class is specifically designed for triggering tool executions in the MCP multi-component processing action system. From Prefab UI, Actions import setState, showToast. Imports two action classes from the Prefab UI module, setState for managing component state and showToast for displaying temporary notifications. From Prefab UI, App import Prefab app. Imports the Prefab app class from the Prefab UI App module, making it available for use in the current scope. This class likely serves as a base application class for building prefabricated user interfaces. From Prefab URX import result. Imports the result constant from the Prefab UIRX module, providing access to a predefined value used for reactive programming patterns in the UI framework. Class bug report base model. Declares a class named bug report that inherits from base model, establishing it as a data model with validation and serialization capabilities provided by the base class. Title, SDR equals field title bug title. Declares a string field named title with a type annotation and assigns it a field descriptor that specifies the human-readable title, bug title, for documentation or UI purposes. The field descriptor provides metadata about the field while maintaining the string type constraint. Severity, literal, low, medium. High, critical equals field. Title equals severity. Default equals medium. Declares a variable named severity with a type annotation specifying it must be one of the literal string values: low, medium, high, or critical. The field function sets metadata for this variable, giving it the title severity and defaulting its value to medium if not explicitly provided. Description, SDR equals field title description. Declares a string field named description with a type annotation and assigns it a field object that sets the title metadata to description. This establishes a model field with validation and documentation properties, where the title will be used in generated schemas or UI representations. Add app UI. Decorates the class method below it with the @app UI decorator, marking it as a user interface component in the FastMCP 3 framework. This decorator indicates that the subsequent method will handle UI-related functionality, though the specific behavior depends on the method's implementation. Def report bug, prefab app. File a bug report. Defines a function named reportBug that returns an instance of prefab app. The function's purpose is to file a bug report, as indicated by its docstring. With column gap equals 4, CSS class equals P6 as view. Creates a column layout with a 4-unit gap and applies the CSS class P6 for padding, assigning it to the variable view for use in the UI structure. Heading report a bug. Creates a heading with the text report a bug using the heading component. This renders a section header in the UI with the specified title. Form from model. Calls the fromModel class method on the form class to create a form instance. The method appears to be a factory that generates a form based on a model, though the specific model isn't visible in this segment. This is a common pattern in web frameworks for automatically generating form fields from database model definitions. OnSubmit equals CallTool. assigns a CallTool instance to the onSubmit parameter. This suggests that when a submit action occurs, the specified tool will be invoked, though the exact tool and its parameters aren't visible in this segment. The line demonstrates event binding, where CallTool is the handler for submission events. OnSuccess equals show toast, bug filed, variant equals success. Assigns a success callback that displays a toast notification with the message bug filed, using the success variant style. OnError equals show toast, failed to submit, variant equals error. Assigns an error handler that displays a toast notification with the message failed to submit, using the error variant styling when an error occurs during execution. Return prefab appView equals view. Returns a new instance of prefab app, initialized with the provided view parameter. This line constructs and returns a prefab app object, passing the view variable as its configuration or dependency. The immediate effect is the creation of a prefab app instance that will use the specified view for its operation. Add app tool. Def create bug data. Bug report SDR. Create a bug report. Defines a tool-decorated function named createBug that accepts a bug report, object as input, and returns a string. The decorator, addAppTool, marks this function as a callable tool within the FastMCP 3 framework, while the docstring indicates its purpose is to create a bug report. The function signature specifies it takes a typed parameter data of type bug report and returns a string, though the implementation details aren't visible in this segment. Return fCreated, data title. Returns a formatted string indicating successful creation of an item, incorporating the title from the data object. The fstring interpolates data title into the output message created, title. FastMCP 3's declarative UI framework shines here by mapping Pydantic models directly to interactive forms, eliminating manual UI construction while maintaining type safety. The bug report model defines the data structure with typed fields, and FormFromModel automatically generates the appropriate input component's text fields for strings and a dropdown for the constrained severity options. This model-driven approach ensures consistency between the data schema and UI, with Pydantic handling validation both client-side and server-side. The reactive architecture connects seamlessly through CallTool, which bridges the form submission to the backend createBug tool. This separation of concerns keeps UI rendering clean while enabling server-side processing. The success and error callbacks demonstrate proper user feedback handling through toast notifications, completing the reactive flow from user input to system response. The trade-off is clear. You gain rapid development and consistency at the cost of some customization flexibility. For well-defined data entry forms like bug reports, this pattern reduces boilerplate while maintaining robustness through automatic validation and type checking. The framework's design choice to prioritize convention over configuration pays off in scenarios where the data model drives the interface requirements.
The literal severity levels, carved in code, weigh each bug report with the finality of a cosmic scale.